Hi, everyone. I hope you're doing well. In this video, I want to show you how you can basically conceptualize the way you work in Stata at a higher level of productivity and workflow, which is an imperative task when you're learning Stata and really most kinds of software. And it'll involve going a little bit deeper into how computers really work, at least on a very minimal level. So thinking about the concept of things such as file structure, which may or may not be sort of a new idea to some people. And it's basically a way that can involve a high learning curve at first, but over time is definitely worth the effort to undertake. So I'm going to use as a sort of example Dofile here. And remember, a Dofile is basically what we would call what's known as a script in other programming languages. As my example Dofile, I will use the basically analysis that I have my students in SOS 360 do, which is the introductory stats class at UW-Madison in the sociology department. And probably many people watching this are in that class currently, but some of you may not be. I've made videos like this on a number of occasions, and I wanted to make something a little bit more general this time that could be, in principle, viewed by people in a variety of different classes. So you may be watching this in the future. I hope this is the last time I end up recording something that kind of goes over the same basic material. And so I wanted to start by just kind of walking through what I call the coding etiquette or basic setup here at the start of this Dofile. So I'll assume that you have access to this file, which I'll post to GitHub or to other relevant places where you can access it. And I'd like for you to try to follow along as I walk through this. This video will likely be a separate video from any particular analysis because it's worth explaining in some detail why we have the setup that you'll find at the start of most Stata Dofiles. So we'll begin. We can just go ahead and run a little bit of our Dofile here. And the first thing to note maybe is that Dofiles are basically just different ways of interacting with Stata than are the command window. So as a reminder, if you open Stata, you won't necessarily have a Dofile open. What you will have open is something like this basic setup. And lots of people actually find, starting at the very beginning here, lots of people actually find that when they open Stata on specific computers, they don't have this history window here. That's something you should fix because really, I think this Stata setup here is the optimal one. And so to fix that, what you ought to do, pardon me, is to come up here to view and ensure that your layout is set to widescreen. You don't need to modify anything else. And then you should be able to see all of this. And you can toggle which windows are available to you by coming over here to the window tab and then selecting things. And so the way that the basic interface of Stata works is this. So you have a place you can type commands here called the command window. So for instance, we can pull up the kind of example auto data set. I'm going to write clear here, comma clear, which is sort of a default thing. It's not actually necessary in this case, but I'll talk more about that later. And you can see that this brings up the list of variables here that ship with that data set. You can see that there's a history of the commands we've run here. So if you're using the command window for coding and you, let's say, run a command, let's make a deliberate mistake. So let's say we want to summarize one of these variables, but let's say I accidentally type like sum arise with too many m's, and then I write, the word mpg or the variable mpg. So we'll see command sum arise is unrecognized. If I want to fix that mistake, I can easily load that command I just ran and then come here and delete one of the m's, and I will get the basic summary statistics for the variable mpg. So this history window is really helpful. You'll also see what's called the properties window here, which if we select different variables, gives us information about the variables. Not something that we often need to look at, but helpful. And then finally, we have the results window, which is obviously where most results of our commands are going to show up. Although unlike some other languages such as Python and R, the graphs in Stata pop up in different windows. So we won't see graphs here. If we issue a command to return a graph, something like a box plot of the MPG data, we'll see here that we have it pop up in a separate window. And my default scheme here, by the way, is different than Stata's. So I'm going to actually set the scheme to Stata's default scheme so that everything you see now will resemble exactly what you get when you have kind of basic Stata. And later on, I'll talk a little bit about schemes, which are helpful things that you may want to play around with a little bit as you progress on your sort of coding way. So that's the basic interface of Stata without using dofiles. So dofiles are written places that you can store commands and also store commentary as well. Actually, most of this you can see on the screen is commentary. It appears in green in this case, although that'll depend on your exact settings. And so dofiles are really helpful because they allow you to create a record of what you did to obtain certain results in Stata. And one of the really signal disadvantages of a lot of other kind of pieces of software that you might be tempted to use, such as Excel, which is many people's sort of fallback when they encounter initial difficulty with Stata, or Python or R, is they turn to Excel or to Google Sheets. But the main problem with such pieces of software is that they don't actually record necessarily what you've done to transform your data. And Stata doesn't force you to do that either, but it does make it very convenient. And at a certain point, it'll just become a reflex to record what you did to your data, which prevents you from making really simple mistakes of the kind, for instance, made in the infamous Reinhart-Rogoff paper, which is a widely told tale. A couple of economists, I believe both at Harvard, one has won the Nobel Prize, published a very famous paper indicating allegedly that there was a strong negative relationship between the debt to GDP ratio and the rate of economic growth. And it was discovered the paper was pretty importantly flawed by basically I believe effectively a grad student in Marxist economics, for lack of a better term. Whether or not you would call it the critique of political economy or Marxist economics is a very secondary kind of dispute there. But anyways, a grad student basically found this mistake and found it by noticing that the author's strange results would have been what you would get if you forgot to extend an Excel formula all the way down to the end of the column. And so that kind of mistake where you're dragging and dropping formulae down thousands and thousands of columns to make sure that you get the results that you want, for instance, and directly modifying your data, and indeed writing code directly into cells where you want, say, new variables to appear, is just really error prone. And it's error prone in a way that oftentimes doesn't leave you with any indication that you've made an error. And I'm saying all of this as someone who used Stata for a long time in a way where I would use it for the analysis, but a lot of data cleaning and management I would do in Sheets or Excel. And a lot of the work that I did at that time is hard to recreate and required me to go back later on when I wanted to update it and use it, to put in an enormous amount of work to basically wrangle the data, as we say. And so I am encouraging people watching this to learn from my mistakes. And from the outset, no matter how minor a project it is, unless it's something truly just sort of transitory that you just want to, jump into Stata and play around a little bit, I would really strongly encourage you to record what you're doing in a do file. I've oftentimes found it useful even to do, things that take 10 lines of code, to go ahead and bother to make a do file and call it something meaningful so that I'll be able to use it later. Okay, so that's basically my spiel about why to use a do file. And then here's how do files work. So do files also run commands, just like the command window does. And do files, generally speaking, the best practice is that they should be written so that you can click do or use a keyboard shortcut. And a very helpful one if you're using a Mac is Shift Command D. By the way, I will mention some Mac specific things in this lecture because I do use a Mac, but there's oftentimes comparable shortcuts for Windows. I don't necessarily know them, but these are the types of things that you can usually use an internet search engine to find out about pretty easily. So I would recommend Shift Command D if you're on a Mac. And they can be, you can run do files all in one go, but generally speaking, that's what you want to do when you finish the do file. So you can run parts of a do file where you are effectively doing the same thing that you would do if you were typing commands into a command window. So for instance, let me go ahead and just show that I can also pull up the auto data from here. And you can see that this has been successfully issued. Might not be that apparent because, I just put the same data set here. Let's use, let's go ahead and actually just like issue another command. So let's say issue a histogram command for, let's say price. And you can see that that pulls it up just the same. I'm showing this example because a lot of the commands we're going to run here won't have really obvious results. So I just wanted to kind of prove to you that this is indeed true. You can also run comments in Stata, these are mostly here for reference for the readers so that you can read them. But it will, the program will put it up on the results window if you run a comment. So you can see that we can get this up here as well. And finally, one last sort of bit of throat clearing before we go further. Notice that there's a number of different types of comments out there. There's actually 3 in Stata. The first is this sort of bracket style comment where you open with a / and an asterisk and then close with an asterisk, then a /. And these are generally, they allow you to write multi-line comments without needing to mark the new lines. And what they do is just kind of allow you to write longer, phrases. Stata, like some other programming languages, otherwise considers that the end of a line is the end of a command. So if you have 2 commands in a row, let's say we have like these 2 right here, I'll just put them right together. You can see that it will run both of those commands separately because the program assumes that the end of the line is the end of the command. And the same is true in a lot of cases for comments as well. So sometimes you want to write multiple comments, and this is a nice way to do it. But the kind of default way of writing a comment is actually just to use a single asterisk, although that runs out after a particular line. So you can see if I start typing a comment, but then change lines, you can see that this now, Stata is going to actually try to interpret as a command, which is not correct. So that makes it nice to sometimes have this other alternative. One other alternative, even still, is to use 2 /, which basically has the exact same function as the asterisk, except the asterisk can be used in the command window. So this works, this does not. But you oftentimes don't want to write comments in the command window. So for the most part, I'll just use these 3 interchangeably as it suits the flow of the do file. For a lot of this early part, I will be using these longer forms of making comments. But later on, I'll use some of the asterisk and double / when I just want to write a quick comment. Okay, so that's a brief aside on comments. So let's go ahead and now investigate some of these parts of the basic setup. And in the future, you should just put all of these things right in a row. You don't need to explain necessarily why you're doing them. But I want to, obviously show you all what this looks like the first time, or why we do it rather. So we're going to first issue this command capture log close. And it's a funny place to start because it involves a couple of ideas that we're not really going to use very often. So first of all, log close tells Stata to close a log if any is open, and a log is actually a way of recording our Stata output in yet one more place. And in this case, it actually records it in basically a text file so that it can be opened later on without needing to like necessarily run the command. So you can send your log files to people without necessarily sending them your do file, and it basically shows everything that you did. And you can log sessions without necessarily needing to have a do file as well. So if you find yourself really in a groove and you're working in the command window, you can open a log there. A lot of times these logs are sort of pro forma in that you may not actually need to refer to them, but it's just a good kind of data management and workflow procedure. The prefix capture is a rarely used Stata prefix that basically tells Stata to not issue an error message if there is no log to close. So we don't have a log open. Let's find out what would happen if I wrote this. And you can see it says no log file open. And if commands issue errors, they generally stop a do file in its tracks. And we don't want that. So there's no harm in telling Stata to ignore that and carry on its merry way. So if I write capture log close, then it's not going to complain that there's no log file open. Be careful with capture though, because a lot of times error messages are there for a reason. Okay, and notice that we don't need to run these comments, by the way, so I don't need to run this here. I can just go ahead and skip ahead. This is mostly here for the reader. So we're going to clear all the data we've been using, and I wanted to say something about that briefly. So as mentioned before, well, let me actually start by saying this. So it might seem weird to clear all because it doesn't ask you to stop and save your data. Sorry about that, folks. I'm a little bit under the weather, so I wanted to briefly clear my throat before going further. So I was discussing the clear all command, and I was mentioning that it's a little bit of a kind of scary thing to do. So let's load some example data. We'll again use the auto data set as we often do when we just do something really quick. And let's now try running the command clear all. You can see that it does just immediately remove everything. It didn't ask us to stop and save. So if we had made some changes to the data, let's say we do this. So oops, a little bit of a typo there. Something like, let's just take the log of price for the sake of it. So we'll say gen ln price equals log, or we should do this, of price. We have a new variable price here. And we could, for instance, take a quick scatter of the two and look at the relationship that way. We can see we have the nice natural log shape. But now if we go ahead and clear the data, we can do this. And then if we once again open up the auto data set, and I accidentally clicked the version with an error in it, and you can see we don't have the natural log of price anymore. So we've undone the work that we did, which might seem a little intimidating, but there's actually a real point to this. And the point is this: you should, generally speaking, always keep track of the changes you make to your data in a do file. The problem with a lot of other programs is that you don't have to record what you did to your data, and in Excel, it auto saves for the most part, or certainly in Sheets or cloud-based, programs, it's going to be auto saving your data for you. So sometimes you might make changes and you are, in the groove and you just totally forget what you've done. And you don't even have to stop to think to save it. It's just being saved for you, which can seem really convenient, but in a way it's a huge drawback because you don't actually have to keep track of what you've been doing. So in general, best practice in Stata is, at some point you may want to save your data once you've recorded all of your changes in, say, a data cleaning do file. But for the most part, if you just have a minimal amount of data cleaning, you should just make those changes in the main do file. Especially if the data cleaning involves creating new variables that you might want to justify to a reader. So in general, it's actually best practice to clear your data and then make changes to the data in the do file itself. As I mentioned here, once you transform your data set, it's your data set and you are responsible for the contents. No longer is the purveyor of the data set responsible. So if you make mistakes, if you don't remember how you created a certain variable, etc., it's really on you, which is unfortunately, can sometimes have disastrous consequences. So it's a really good practice to force yourself to document what you're doing by putting this clear in here. And it also means that when we use commands later on, such as use to indicate that we want Stata to load in a particular data set, we won't get an error message because Stata, unlike many other pieces of software, is only uses one data set at a time, in contrast to R or Python. Okay, so we can go ahead and clear all here. And we're going to set more off. This is sort of antiquated. Basically what this does is tell Stata that we want to basically show us everything that results from a particular command without basically limiting what comes out of the command in the command window. So this is one of those things we just don't need to worry too much about. It's sort of standard. It undoes default in Stata that most people don't find useful. Okay, so that was a bit of a minor thing. Let's actually talk about something much more substantial now. So what we want to do next is change the directory. CD stands for change directory. And what we want to set this to is our working directory. And so first of all, directory is a folder, more or less. So those are the same thing. And what we want to do is have a directory And by the way, the concept of a directory or a folder might be kind of novel to people. I don't say that in a disparaging way where, I am trying to crack on, younger generations who have kind of grown up with computers so ubiquitous that sometimes you don't necessarily need to know that much about how they work. Kind of in the same way that I would imagine when automobiles were kind of newfangled technology and, more prone to error, people likely had to know quite a bit more about cars in order to operate them. And now it's so effortless that most people who drive cars, even people that might, drive cars really well, like they're perfectly good drivers, safe, they know the rules of the road and stuff, might have very little idea of how a car actually works. And so I'm saying this again, not to disparage anyone, but just to say like, this might be a new way of thinking about things. So a folder is a place, it's a way of storing things on your computer that's really analogous to the real world concept of a folder. In other words, a container for things. So what we want to do is basically here put into a particular container all of the material that we're going to use for a particular project. And generally speaking, if you are an undergrad or grad student, the best way to organize these is usually for particular classes, as long as you're still in classes. So I went ahead and did that. Even as an instructor, I just made a folder that corresponds to basically this class. If you don't have a folder already on your computer, you can make one. I'll show that briefly here. So I think it's oftentimes easiest to put these things on the desktop. You can also put it in documents. So making a folder is as simple as this. And you can see there's a lot of screenshots because on Mac, that's where screenshots saved by default. You may want to, you can actually change that default preference, by the way. I need to do that. I undid it at one point and need to change it back. But creating new folders is as simple as going to Finder, hitting File, and then New Folder. You can also do it from within Stata as well. So you can write this, make dir or make directory, and then I'm going to put it on the desktop and I'm just going to say example folder. And you can see, whoops, that's put this folder here. I should explain briefly that on Macs, and I think in general on like Unix systems, if you want to invoke basically the base user, so you want to skip the step of writing user and then your username, you can just put a tilde, which is the squiggly thing that indicates kind of a nasal sound in Spanish and Portuguese. That's the main linguistic use. I guess a couple of other languages too, but mostly Spanish and Portuguese. But also in math, it has many meanings, some of which are confusingly almost opposite. But in computing, this is one thing that it can mean. It's sort of like go to the base. So I would recommend making the folder basically, in a place that's easy to access. So don't make it within, try not to nest it in too many things. And generally speaking, it's a good idea to not have spaces in the name of a folder, because if you do have spaces, then later on, you will need to always use quotation marks when you call a folder. So if I change the directory here, I actually don't need to have these quotation marks, and you'll see that we don't get an error. But let's make a silly example. So let's say, like this, you can see it makes a folder called silly example. Now, if I try to change to this silly example, so let's go back to Stata. I don't use quotation marks, Stata is going to get mixed up because you can see there's this space here, which doesn't like. So we would have to use this. And this is just one more step you have to take. Now we're in this folder. So you can see, let me actually illustrate the concept of a working directory this way. So a working directory is basically where Stata is going to look for data and then also store output, unless you tell it to do otherwise explicitly. So let's make another folder and let's just call this EG2. So we'll say EG2, and you can see that if we come here, it's not on the desktop because we changed our working directory. It's actually in this other folder here. So that's kind of the power of a working directory, is that it is the place Stata will store things unless otherwise told, which is often convenient. So let's go ahead and delete these because they're not necessary. And we'll empty the trash while we're at it. So coming back to our folder here, by the way, it's not a bad idea to pin things on the sidebar here if you're going to be using them often. So let's go ahead and kind of see how we could use a working directory to our advantage. So one thing that it lets us do is, for instance, load in data from, let's say, a specific data folder with relatively few keystrokes. So I went ahead, well, actually, we should double check that we're in the right working directory. And you can see here, we're actually not. This is where Stata lists the working directory, but the command pwd also lists the working directory as well. And sometimes you'll see this interesting thing come up as well, where macOS refuses to provide that information. I actually don't remember the solution to this, but at any rate, it's always listed down here. Oh, it might be because this is in the trash. Yeah, I think that's actually probably what it is. Let's see if changing it back fixes that. Yeah, so if you trash something, then it'll show that it doesn't, can't provide that information. But if you just type pwd, it'll print the working directory. So we're now in the right working directory, or at least the one I wanted it to be in. It could be right or wrong, depending on the project. And now you can see I can call in data relatively easily. Like if I didn't have the concept of a working directory and I wanted to try to load data, what I would have to do is something like this. I would have to go to a file, like let's say the GSS 2018, which we'll use later, and I would need to get the file name, and we would copy the file name as a path name. This is going to be a long path name, and then I would need to come here and write use this. Then if I do that, it loads. But let's say that I didn't do that. Let's clear all. And let's say I'm just being lazy or I forgot, and I'm like, okay, what if I just use GSS 2018? So let's actually just change the working directory to the desktop so we do get an error. And I say use GSS 2018. You can see the file isn't found because it's somewhere on my computer, but Stata only knows where to look if I don't spell out the whole file path. It'll only look in the current working directory, or the current directory. That's a little bit redundant. And a lot of times a confusing thing can happen too, where we have data load, like maybe sometimes a kind of common amateur mistake, for instance, might be to load some data. Let's go into another folder that's got data in it. So let's come to, from when I taught Social 365 in the spring, and let's go into the data folder, and I will pull something up here. Let's pull up, I don't even know, totally irrelevant. Let's pull this up. So you can see this loads the data into Stata, which is nice. And that means that anytime you want to just download data and load it, you can do that. But you'll notice that it's changed the working directory to that folder, which is something that often escapes people. And then they save results in folders that, you know, depending on where they pulled the Stata data from, may not be accessible to them easily. They may not know necessarily like even what folder they're in. And it can be really confusing. So the better way to load data is to change to the relevant directory and then just type the command use like this. So let's change back to the folder we want to be in. So we can do that in a variety of different ways. One way is to just come up here. We see that this is the folder we wanted to be in. So we can just come back and write cd like this, or we could use it in the Dofile here. And now we can just go ahead and pull the data. Now I do use a subfolder structure because I find it helpful to have multiple folders in here. So one that contains data, one that contains code. And then you can see this is actually just misplaced. So we'll put that into the trash. So we do need to invoke one more folder here. But the nice thing is that there's actually a shortcut for that, again, at least on Macs, which is that you can put a dot or a period and then write / folder you want to be in / the data. And basically this dot just says, okay, within the current working directory, go look one subfolder in, and then you just write the name there, and then you can pull up the data. So now loading the data is as simple as this. And you can see we've pulled it up like that. So that's really cool. Finally, our last step, or one of our last steps really, is that we're going to go ahead and just log the data, or the do file, log the commands we're going to use, which I alluded to earlier, so I won't re-explain that. The one thing is you may want to make sure that the directory is set precisely here. So in this case, I would probably, let's actually make a directory. I made this folder relatively recently, so I might want to put the log in a specific place. So let's actually make a directory. So we'll say make dir, and then let's put it in code, and we'll just call that logs. And then we will come here and we'll log this here. And let's do this. And the replace, by the way, make sure that the most recent iteration of what we run represents the log. Now, you may not want that on there necessarily if you want to log a particular run of a do file and then not replace it, but that's usually not the case. One thing that can just sometimes cause confusion is if you happen to run part of a do file and then stop, then the most recent log will represent that stopped version. So there's just something to watch out for. But let's take a look at an example here. Let's just tabulate, let's just say relig. And then we can close the log. And we can come here and look and see what we got. Go into the logs and come here, and we see it pulls it up in this somewhat easy to read format here. And there's a variety of different ways to log things too. So you can actually pull up the help file for logs and see that there's, if you come down here, by the way, this is just a nice, so somewhat deliberately a nice way to just go ahead and show you how a help file works, because those are very helpful. So these are great. One nice thing about Stata that is an improvement over many pieces of free software, which also have their own advantages, is that Stata has really extensive help files. They're oftentimes very beautifully written. So many of the people that write them have an excellent style. They're very convincing. They read like good textbooks, as opposed to a lot of things you might find in fora online, where you might have people that are really brilliant at coding, but not necessarily always the clearest writers, right? People that might be making all kinds of grammar errors that are, you sort of have to sit down and actually work through it. But the Stata, basically the Stata books that ship with Stata for free are really, really nicely written. So they're very easy to read. If you do find it difficult to read the help file, which I often do, you can just open up the PDF manual entry. So you can see here, you can, for instance, redo this as text, which is actually usually how I like to do that. So let's add text. And we'll come here. Oh, we need to do one quick thing here. Oh, characteristic mistake here. I was wondering why that wasn't working. Always check the working directory, and I didn't actually do that on purpose. So the point here, the reason that wasn't working is that by opening that log file, we actually inadvertently changed the working directory. So this file path actually no longer makes sense, because it's telling Stata to look in SOS 360 fall 22 code logs, and then look for a folder code logs again. So we need to do this. So we'll do this. And now you can see it's worked. Let's try the same thing again. And we'll close the log. And we'll come here, and you can see that this opens as a text file like this. So that's where I will leave off here. Hopefully this is a nice introduction to the basic framework for using Stata at a bit of a higher level. And I'm going to also probably for most people direct you to now go watch a later part of this, which deals with the actual data analysis. Thanks for watching.